Hi everyone, welcome to the first session of Unit 1, Some Basic Concepts of Chemistry of Plus 1 Chemistry. One of the important aspects of subject of chemistry is study of chemical reactions. And these chemical reactions take place according to certain laws. So today in this session, we will discuss about laws of chemical combinations. The combination of elements to form compounds is governed by the following 5 basic laws. Law of conservation of mass, law of definite proportions, law of multiple proportions, Gay-Lussac's law of gaseous volumes and Avogadro law. So let us discuss in detail about these laws. The first one is law of conservation of mass. The law was put forward by Antoine Lavoisier. The law states that matter can neither be created nor destroyed. So let us discuss this with an example. Consider a reaction. C plus O2 gives CO2. So here the atomic mass of carbon is 12 gram. Atomic mass of oxygen is 16. Since here we have 2 oxygen atoms, we will write 32. And for carbon dioxide, it is 44 gram. That is 12 plus 32. So here, carbon and oxygen are the reactants. And this is the product. Total mass of the reactant is equal to 12 plus 32, that is 44 gram. Total mass of product is equal to 44 gram. That is, during a chemical reaction, the total mass of the reactants consumed is equal to total mass of the products formed. There is no increase or decrease in the total mass of the matter. Our next law is law of definite proportion. This law was given by Joseph Proust. The law states that given compound always contains exactly the same proportion of elements by weight. So let us illustrate this with examples. So consider the first example. There is CO2, that is carbon dioxide. There are different methods by which you can obtain carbon dioxide, such as burning of carbon, then the action of dilute HCl on marble, heating of sodium bicarbonate, etc. So whatever be the source from which it is obtained, the given compound, that is carbon dioxide, always contains the elements carbon and oxygen combined together in a fixed ratio, that is 12:32 or 3:8. Now let us take another example. That is pure water. There are different sources from which water is obtained. For example, well, rivers, lakes, etc. So irrespective of the source, the given compound water always contains the elements hydrogen and oxygen combined together in a fixed ratio, that is 2:16 or 1:8. So this is law of definite proportions. A third law is law of multiple proportion. This law was proposed by John Dalton. According to this law, if 2 elements can combine and form more than one compound, masses of one element that combine with fixed mass of other element are in the ratio of small whole numbers. So let us illustrate this with examples. Consider the first example. Hydrogen and oxygen combine and we get two compounds, that is water and hydrogen peroxide. So here the atomic mass of hydrogen is 2 gram. Since we have 2 hydrogen in water, it is 2 gram. And for oxygen it is 16 gram. We have only one oxygen atom. And altogether for water it is 18 gram. Then in hydrogen peroxide we have 2 hydrogen atoms. So here also it is 2 gram for hydrogen. Then 32 gram for oxygen. We have 2 oxygen atoms in hydrogen peroxide. Then altogether it is 34 gram. Here you can see that the masses of oxygen, that is 16 gram and 32 gram, that combines with fixed mass of hydrogen, that is 2 gram, bear a simple ratio, that is 16:32. Or 1:2. Second example to illustrate the same law. So here carbon and oxygen combine and we get carbon monoxide and carbon dioxide. So let us write the masses. For carbon it is 12 gram. We have only one carbon in carbon monoxide. And oxygen it is 16 gram. And all together it is 28 gram. Then in carbon dioxide again we have only one carbon atom. So the mass of carbon is 12 gram. We have 2 oxygen atoms in carbon dioxide. So it is 32 gram. All together it is 44 gram. Here you can see that the masses of oxygen, that is 16 gram and 32 gram, that combines with fixed mass of carbon, that is 12 gram, bear a simple ratio, that is 16:32 or 1:2. Now the next law, Gay-Lussac's law of gaseous volume. This law was given by Gay-Lussac. The law states that when gases combine or are produced in a chemical reaction, they will do so in a simple ratio by volume, provided all gases are at same temperature and pressure. Now let us see some examples. First example, H2 plus Cl2 gives 2HCl. Here, 1 volume of hydrogen react with 1 volume of chlorine to give 2 volumes of hydrogen chloride. So this is a gaseous reaction. All the reactants and product is in the gaseous form. Here the ratio between the gaseous reactants and product is 1:1:2. Second example. N2 gas plus 3H2 gas gives 2NH2. NH3 gas. Here, 1 volume of nitrogen reacts with 3 volume of hydrogen to give 2 volumes of ammonia. So let us see the ratio here. One is to 3 is to 2. In both these reactions, you can see that there exists a simple ratio between the gaseous reactants and products. Now let us move to the last law, that is Avogadro law, put forward by Amedeo Avogadro. The law states that equal volumes of gases at same temperature and pressure should contain equal number of molecules. That is, if you count the number of molecules in different gases of same volume at same temperature and pressure, you will get same number of molecules. For example, take 5 liter each of different gases such as nitrogen, oxygen and chlorine at same temperature and pressure. Then all of them will contain same number of molecules. So let me conclude this session. So today we studied about the 5 basic laws of chemical combinations. The law of conservation of mass by Antoine Lavoisier, the law of definite proportions by Joseph Proust, the law of multiple proportions by John Dalton, Gay-Lussac's law of gaseous volume by Gay-Lussac, and Avogadro law by Amedeo Avogadro. Thank you.